Happy Monday, everyone. Hope you all had a good weekend. From what I sound, it was a busy weekend for many of you, but productive weekend, hope. I just wanted to say thank you very much. 24 out of 24 on submissions for the assignment. I don't expect there to be few or that many left out, but 24 out of 24 is a pretty good accomplishment. It means we had 100% submission, so I'm pretty happy about that. I do have a real quick update. So we've got three more chapters that we're going to be covering before we go to the next exam. So we're doing chapter 12 today, chapter 13 next week, and chapter 14 the week after. This is what I call the start high, go low, and start high, because this chapter is actually pretty interesting. You see, it's emerging technologies. I actually really like this chapter. Then chapter 14 is going to be about cybersecurity and fraud, which is an interesting chapter. But then chapter 13, we've got internal controls, which I love internal controls personally, but they're not one of those things that stimulate excitement among students. Okay, so one of the things that I say to students is, if we're going to do this internal control chapter, you got to be ready. And I made the joke when I first started teaching this version of the course last year. Said you need to slam a Red Bull or get some caffeine or whatever you're ready. And then I actually brought Red Bull in for my class, and I stopped doing it because nobody was actually taking the Red Bull. Okay, so if I bring Red Bull, how many people would actually like one for next Monday? Okay, all right, I'll bring some Red Bull. Okay, I'm not going to bring 24. Maybe I'll bring a couple of cases since I only like about half people to the class. Now, if you didn't raise your hand and say I'd like a Red Bull, Dr. Barnes, until we run out, okay, I don't want you putting that in my evaluation. Say we ran out of Red Bull. Okay. But I'll try to make that accommodation because, again, today, interesting. Next Monday, not so much. All right. But a very important chapter that we have to go through. Yeah. So we'll see what happens with that. By the way, if you do get a Red Bull and you open it up here and spill it on the computer, it was not my fault. Okay. It was entirely the blame. So maybe bring a container that's got some sort of lid on it if you're going to drink a Red Bull. Yeah. In the past, basically what's happened is that any of the Red Bulls they don't have, they just go on the snack cart. And some people say like, oh, it's a treat, and they start showing up expecting Red Bull every single day. So I don't know. I think that's a generational thing. I tried a Red Bull one time and I said, never again, never again. I'm just old that way. All right, today we're going to be talking about stuff that's not old. We're going to be talking about blockchain and AI automation. Some of this is going to look very familiar. Some of this is going to be somewhat new. We did talk a little bit about blockchain with the context of how it worked. We did that fraud project, or the top fraud research project right before spring break. So I do want to refer back to some of the things that we talked about and maybe introduce some other concepts. And the stuff that was in that presentation, you're not responsible for the exam. That was just mostly a learning experience. The stuff that I'm about to talk today, absolutely important to know for the exam. So the origin of blockchain is, everybody heard that term blockchain before, okay? Now, blockchain is very interesting in the way that it's set up and the way that it was created. We tend to think of blockchain as the mechanism for crypto assets, particularly cryptocurrency. And that is true, but it's a simplification of the task. It's a simplification of the task. And so I do think that the interesting thing about blockchain, as far as it goes to setting up how do we create new blocks on the chain, and how does that actually facilitate the generation of crypto assets? That's an interesting story. That's actually part of the research project we did. I don't think that we did that in this class. We talked about FTX and we talked about accounting for crypto assets. But that's another thing. We talk about how does blockchain and cryptography work. And it's a fascinating story, which is well above my head. We're going to allude to it a little bit. So the whole idea behind blockchain was created in a white paper called Bitcoin, a peer-to-peer electronic cash system. And I believe this was 2008, could be 2009. I always get the date a little bit messed up. So it's not quite 20 years old. This is the origin, the synthesis of crypto assets, which basically means that cryptocurrency and crypto assets have existed for most of your lives here. At some point, I'm going to talk to students and I'm going to be telling the story, and they're going to say, that was before I was born, Dr. Barnes. And then I'm going to feel really, really old, okay? Because I can remember back in 2008 and 2009 what was going on. But the idea being is that this is right around the time of the subprime financial crisis, which was big worldwide global crisis. And everybody had low confidence in banks. And the idea behind this was, let's create a distributed ledger system where we don't have to rely on banks. Because the whole point of banks is that you have to rely on somebody else to hold your assets and maintain transactions for you. So if people could do that on their own, it would be a lot more convenient. And so the whole point was to use a distributed ledger system. The distributed ledger is basically all computers have a copy of this ledger. It's not one central location that sends it out. It's that all locations store copies of this ledger that are updated simultaneously. Then there's this resource-intensive mining, which I don't want to go into a lot of detail on this because there's a lot more to it than I'm about to tell you, but I will give you a guideline. Is that the idea behind updating this ledger is that anybody who can basically what's the word I'm looking for? Who can approve the ledger? That's not the right word. Who can verify the ledger? Who can verify the ledger? They get rewarded by an award of crypto assets. In this case, Bitcoin. And the ledger approval process is not so much as just look at a ledger and say, "Oh, that looks good to me." Okay, there's actually a pretty significant crypto hashing algorithm that goes into that process, which relies on a lot of computing power. But that means that the transactions that go onto the ledger, they're permanent and they're not susceptible to fraud because everybody has to agree them on the same time. But resource-intensive mining was a really important point to that. Verification of ledger is what we consider to be the mining process. And you've probably heard of crypto asset mining and cryptocurrency mining. The verification process generates a lot of interest because people can actually have these crypto assets given to them. And that's how they acquire new crypto assets. And so some of the older crypto assets like Bitcoin now have a massive stake, $100,000 for a Bitcoin, so single Bitcoin. The whole goal was to eliminate financial intermediaries, which the book refers to as middlemen. So the idea being is that when you engage in a transaction with a second party, that you have to have a third party oversee that transaction. Think about what happens when you go to the grocery store. Unless you're paying with cash, you're automatically engaging a third party in your transaction. So when I went to Hy-Vee to buy my groceries last night, I pulled up my trusty credit card and I said, "All right, here's how I'm paying for the groceries." What's happening there? I'm saying giving access to Hy-Vee to my bank account, and they're charging that bank account with that card. And so the third party is actually being involved in the transaction. And there's a number of problems with that because I have to have the resources on hand in order to be able to pay for the transaction. I've actually got to facilitate financing of that transaction. They have to be trusted with the assets that I provide them, and they have to make sure that they engage the transaction to the benefit of Hy-Vee so they actually receive the resources. So the whole process requires a lot of trust. Okay, it requires a lot of trust in that process. With the elimination of financial intermediaries, there's no third person. There's no third party. Okay, so it's online, it's faster, they're a lower cost. It's peer-to-peer, which basically means that the two parties are engaged. So if it was like the transaction I talked about yesterday, it would be me directly giving resources to Hy-Vee through the transaction. And it's considered to be a trustless system. Now, I've got on my notes here in trustless, I got supposedly, okay? The idea behind trustless system is that there's no need for trust in that particular process simply because you aren't engaging a third party, so you don't have to trust anybody else with their resources. That has kind of come to skepticism over the past few years. We talked about that again with our research project we talked about earlier this semester. The idea of trust not being necessary anymore because of these blockchain systems has kind of come to doubt with the blockchain trading scandals and the platforms that have been kind of held into concern. FTX was the example we talked about in class. There's also another company called Binance. Has everybody heard about Binance? Binance has got a lot of problems going on with it right now simply because of money laundering concerns that they've had. So trustless is going to be kind of maybe. Is it trustless? Possibly. We do still have to have some trust in another party, but they're not a regulated party, which is certainly problematic. So what are we talking about when we talk about blockchain, okay? Blockchain is basically a center. We're talking about it's not a decentralized system. So comparison for a centralized transaction system, this is what we already know about. A centralized transaction system, we would record it in one spot, and that one spot would actually be the basis, the core of the transaction system. So we think about an AIS system in this course, even though we all have access to NetSuite, the NetSuite database, the NetSuite storage, is going to be on one server, and that's where everything gets updated to. So it's a centralized system. It requires an intermediary for recording approval, and there's one copy of the ledger. Now, one copy of the ledger can be accessed by multiple parties, but it's still just a single copy. If that copy gets corrupted, then the ledger itself is wrong, okay, and it gets corrupted itself. The idea behind the blockchain transaction system is that we're going to decentralize and distribute this. So every party on this system is going to have it. So imagine that we're all in this room, and we're all in a blockchain together. We would all have copies of the blockchain ledger on our computers. It would be individual copies on there that aggregate and update automatically. So there's no intermediary necessary. There's synchronous updates, which again, you'd have to have synchronous connection. But when one person enters a transaction on the ledger, everybody in this room, their computers would update with that transaction update. And the whole point is to be fully transparent. Now, has everybody heard the term transparency as it relates to business and accounting? Okay, that's an important term with respect to business and accounting. Would we prefer more or less transparency? And the answer is almost always more. Think about the 10Ks that you read in other classes, the financial statement analysis you've done before. The whole goal of that is to provide insight as to what the organization is doing. The more transparency they have, the better people can make decisions about the operations. So a fully transparent system is going to be preferable to a less transparent system. All right, so why do we use blockchain? Well, it does allow multiple parties to collaborate using a shared system. It greatly accelerates the speed of transaction verification and settlement. It reduces costs associated with external verification, generally because we do not need external verification, at least not the way we traditionally think about it. It also shares system transactions with all parties. Like I said, if one person enters a transaction on the system, then everybody in this room who was on the blockchain would actually see the transaction and be able to verify it. Right? Once transaction confirms, they cannot be altered. Now, this one's an interesting one. This one's one that I got into an argument with several years ago on a capstone paper with a student. They were saying fraud is impossible in a blockchain system. And they are making an excellent point. It says once a transaction goes on the system, you can't alter that transaction fraudulently. You can fraudulently enter transactions on the system, though they can be caught by the transparency of the system. But for the most part, the change in the system, the manipulation of the system is not possible simply because of the transparency level. There's a lot deeper explanation to that. If you really want to go, if you want to learn about how this manipulation cannot be altered, you can actually go onto YouTube, and there's numerous videos that talk about how cryptography in a blockchain system works. It is fascinating. It is way above my head. And when we're saying talk about way above my head, I consider myself a fairly intelligent person. Watching about halfway through the video, I was like, okay, I'm just completely, totally lost. So there's some interesting stuff going on there. The verification process does prohibit manipulation of transactions, which is ultimately going to be a benefit, assuming that the transactions are entered properly the first time. All right. So what are the types of blockchain that we're concerned about? All right. Well, in the book, it actually talks about three versions of blockchain system. I wanted to talk about a fourth one because it's becoming increasingly prominent over time, and so I'm assuming the later versions of the books will include this fourth one as well. The ones that the book talks about are public, private, and consortium blockchain. So a public blockchain is just as it sounds. Everybody has access to it. There is no central authority. There's no permission to process associated with it. Okay, so if you wanted to access the blockchain, you have access to the blockchain, and that's all there is to it. Then we have permissioned processes, which are going to be private and consortium. Private is going to be controlled by a single authority. So one party actually determines who gets access to the blockchain, and they're going to be the ones who provide the permission, the access to the people or the users on the system. Similar to that is going to be a consortium blockchain, but instead of having one party that can provide permissions, a group of individuals or a group of parties, a group of organizations can provide permissions. So the big distinction there is that instead of one party actually making access decisions, it's multiple parties that can make access decisions in a consortium. Now, the one that's not in the book, but I think it's really important to talk about, is going to be a hybrid blockchain, okay? And a hybrid blockchain, you can see the Venn diagram. It actually has an overlap between the permissionless process and the permission process. Basically, it's controlled by a single authority, but there is some permissionless process that allows public users to get access to it. So there is oversight of the blockchain, and there is permissions for certain parts of it, but for access, generally speaking, it's still going to be a public access channel. So hybrid, again, becoming more and more popular, especially as we start seeing more of an integration of blockchain and cloud computing. All right, so what are some opportunities that we have in blockchain? Well, one of my favorite things with respect to blockchain has to do with this concept of continuous auditing. So this is something that I ranted on in a presentation a few years ago. We've got organizations right now that are in the trillions of dollars as far in terms of market capitalization, and we're still kind of treating them the same way from a financial reporting perspective as we would other organizations. It's more likely these organizations have extremely high levels of technology. The example, the world's largest companies, anybody know what that is? Give you hints, the name of a fruit. Yeah, it's Apple, okay? Apple. So they are literally 4 times larger than General Electric was back in 2002. So 20 years ago, literally 4 times larger. Now I know inflation takes part of that, but I think General Ledger at the or General Ledger, General Electric at the time was 345 billion, whereas Apple is like 1.21 trillion last time I checked. And so very, very high technology company, meaning that they can integrate high levels of technology for their financial reporting if they wanted to, and yet they don't. So this is an opportunity for them to say, instead of doing the periodic audit process that we've all learned to know and love, let's continuously update financial reporting. Let's continuously audit the information. Also, smart contracts, okay? Smart contracts, not the ones that we would talk about in Professor Templeton's class. We are talking about something along those lines. But smart contracts from a blockchain perspective are basically transactions that automatically trigger when certain conditions are met. Now, this is going to be a simplification, and I know that if you know anything about smart contracts, what I'm about to tell you is not the complete picture. But imagine that you go onto Amazon and buy something. As long as you have all the criteria that are met within that Amazon transaction, the Amazon server will be able to conduct that transaction on its own. Smart contract works very much in the same way, except it looks at multiple protocols simultaneously. It looks at all the elements of the transaction that need to be met. If all of them are met, it will initiate the transaction along with all the accompanying details that are associated with that. So smart contract can be very, very beneficial, particularly if we're talking about transactions that are continuous and rapid, and organizations need to be able to actually have mechanisms in place that can handle the multiple transactions that are continuously going on without having had to worry about personnel necessary to engage those transactions. Also, new job opportunities and non-traditional roles. Okay, if we talk about non-traditional roles, think about the nature of the way business has changed over the past couple of decades. A lot of times we tend to think that oversight tends to be a manual process, and review of transactions tend to be a manual process. But now we're seeing that transactions and technology are starting to catch up, and where they can do things that we used to do manually even just 10, 15 years ago. So actually having the ability to perform those transactions, to be able to perform those roles, is really, really important. Having some understanding of how the blockchain works and how the technology operates is going to be really, really important, simply because there's a gap between people who understand technology and people who understand business and finance. So having that overlap in protocols and that overlap in that area is going to be really important. And then, of course, the evolution of crypto assets and cryptocurrencies as well. I will be honest, I'm still a little bit skeptical about cryptocurrency. I've never invested in crypto assets, at least not personally. I do have an investment advisor, and maybe they're starting to do that now with a little bit more of the diversity, because that might actually diversify the portfolio somewhat. But some of these are established, like Bitcoin. Okay, some of these are a little bit more suspect, like HODL. Okay, some of these are just completely and total jokes and have become realistic things. Is everybody familiar with Dogecoin? So that actually started out with the Steve Levina meme, which was the Doge meme. Okay, and it was created as a joke to make fun of people who will actually buy anything. All right, it was created as a joke. It was a meme coin. Was basically what they talked about it. It's not really a meme anymore because it actually has a market capitalization of like $60 billion. So that's one of the best. I've never told a joke worth $60 billion. I would love to be able to have that kind of joke right there. So yeah, that's going to be some opportunities that we have available there. Now, the challenges are that important protocols are not present. Okay, speed, confidentiality, and oversight are really problematic with blockchain right now. Actually, when we talk about speed, we're talking about the governance of what processing speed do we need to actually be able to have continuous updating. We have a lot better technology now than we did 10, 15 years ago. We're still not quite there because it uses a massive amount of data and a massive amount of resources, and so the necessary speeds are not quite there. Confidentiality is certainly a problem. With transparency comes the problem with privacy. If everybody can see a transaction, then there's not going to be privacy within the transactions. And governance. When we talk about governance, we're talking about supervision and oversight by a external body. A lot of the governments worldwide have been very, very skeptical about getting their hands on this. Some like China, for example, have basically said, you know what, we're not going to allow this in the country. I think they've relaxed those restrictions, but for a while there, they weren't allowing the crypto asset transactions within the country. We're getting better on this, but we're still not nearly as far along as we need to be. But we're starting to get better on it. Current enterprise systems, they're not compatible with blockchain technology. So keep in mind that the current enterprise systems that we operate with were generally developed in the 90s or 2000s. They've become continuously updated, and they've faced a lot of challenges in the fact that the technology that we use as business professionals now is a lot different than what we used 20, 30 years ago. Cloud computing is certainly one of those areas that's been a big evolution. Blockchain is one of those ones that they've been very slow to adapt to, even though we know that blockchain technology can be a lot more beneficial, particularly with the transparency and speed of the transactions. Skill sets necessary for blockchain are lacking. I will say I don't teach how to do blockchain accounting in this course. I doubt that you're going to actually encounter many courses where you'll learn how to do blockchain transactions or cryptography. You're going to learn the basics and the high oversight. But if you go out to the real world and say, all right, we would like you to go ahead and enter transactions in the block and then verify it. My guess is there may be people in this room who are going to be able to do that, but they're not going to learn that through most of the technical skills that they learned at Truman State. That's probably something that we should be a little bit better about. We did have instructors who were skilled in that area, but like I said, the data knowledge and the technology knowledge tends to be separate from the business and finance bookkeeping knowledge. Those are two different skill sets that don't overlap very closely in academics, which is something we probably need to improve upon. Blockchain systems, they're difficult to evaluate, regulate, and govern. We talked about that before. If people don't understand it, it's very hard to make rules about it. U.S. government does their best sometimes, but hence we have Sarbanes-Oxley. But if we don't understand what's going on in a particular area, it's very difficult to make effective rules. So yeah, that in a nutshell is going to be what we talk about when we talk about blockchain. Blockchain, I think, has got a lot of opportunity there. It's going to continue to improve over time. We're going to have to wait to see if this is going to be something that can get incorporated into business models, traditional business models as we know of. But with that, we're going to talk about something we've talked about a little bit already in this course. We're talking about AI. This is going to be less about how to actually use AI tools and more about the general placement of AI in business and technology where it sits right now. So it represents computerized performance of tasks that are traditionally associated with human intelligence. We think about AI, we tend to think about their use of logic, rationality, visual perception, speech recognition, and language translation. Those are some areas where AI tools have been developed very heavily over the past decade, and we're starting to see a lot of benefit and a lot of permeation into our everyday lives nowadays. I was watching a YouTube video because I'm not old, I'm hip like you guys, and I watch YouTube. So I was watching a YouTube video where a blogger, I guess is what you would call him. Okay, I'm not hip like you guys, I'm really old. All right. A vlogger was taking a trip to Japan and knew not a lick of Japanese, so basically had his phone out the entire time. And whenever he had to communicate with somebody, he would just ask the question or say the statement he had into the phone. The phone would automatically translate to Japanese for whoever he was talking to, and then the person would respond in Japanese and would translate it back to English. And that's Star Trek type stuff right there, guys. You know, if you watch the old TV shows, they talk about the universal translator. We're actually at that point now. The only thing we have to do is all go to space. Okay, so yeah, kind of cool the way things have changed over time, and we're in that modern frame right now. Now, this is a little bit of an outdated statement, but McKinsey Global Institute predicted that AI could create $5.8 trillion in value across all business sectors. I will say right now that that's probably an underestimate. This is a 2021 book, and AI has blown up a lot more than a lot of people have said. I may redact that next year, okay, or next semester even, because AI's rapid pace of improvement is not maintained. In 2023, they were saying every 8 months it was doubling in capability. It couldn't keep that pace up forever, okay? It's actually slowed down a little bit, but it's still, again, kind of ever present in our society. When we talk about AI, it's also referred to as cognitive technologies. Only reason I have that note in there is because the book actually refers to it as cognitive technologies, and it may come up in your homework. So if you're asking, is that a test question? It's like, probably not, but who knows? You know, maybe I'll feel whimsical and ask that. But yeah, you may hear that term referred to for AI. So what are some examples of AI that we're fairly familiar with? Well, one of my personal favorites is bots, okay? And by the way, there are some overlap in the ones we're going to talk about. There's not an exclusive category where one falls cleanly in the other. When we talk about bots, I tend to think of Siri. Hey, Siri. Say hello to my AIS class. All right. Okay. Apparently not. All right. So bots, generally pretty intelligent, and they become more intelligent over time. I will say that this AI tool is something that's been in place a long time. I think we tend to characterize it as AI, but it was not a true learning technology. It was capable of doing some fun things. It's always a good time when you pull out your iPhone and you say, "Hey Siri, tell me a dad joke." Okay. It comes with
asked my dad to teach me how to drive a stick. He said, maybe we should start with a car.
All right, that was unintentional, but still pretty funny. Yeah. All right. How to drive a stick. Maybe we should start with the car. Yeah, all right. That's actually kind of a joke I would tell. I'm going to move on from this. There's no thing after that. All right. Then we have my least favorite form of AI, which is natural language processing. Okay. So have you ever gone to a website and the chat window pops up and it says, "Hey, I can help you. I can answer any of your questions right there." All right. Have you anybody ever gone to a website like that? Do not click on that window. It's an exercise in abuse right now, I'm going to tell you. I will say that this is probably something that's going to improve over time, but natural language processing is supposed to be along the lens of large language models. It's supposed to be able to predict what the response should be based on what your input is. It's not trying to solve a problem for you. It's trying to actually determine what do you want the response to be. So natural language processing is used very heavily in these chat bots that are used online very frequently. They can record information and they can forward it to the proper authorities, but a lot of times you're just basically working in circles right now. So I tend to avoid the chat bots like the plague that are online, or the chats. Calling them chat bots is not a fair statement. The chat systems that are available for customer service. It's interesting. These automated customer service tools that are using natural language processing are becoming a lot more prominent. Okay. There was a company called Decon. This is about a year and a half ago. They laid off 90% of their support staff. There's a customer service company. They laid off 90% of their support staff so that they could actually move to automated customer service. Now, if you were an employer who was working at Decon, you probably were a little bit ticked off about that because that's a pretty large number of 90% of the support staff. That being said, it's very interesting to see that that's the transition we're moving in. There's enough confidence thinking that we can actually achieve customer support through AI tools. Something that's very relevant and should be relevant to a lot of you all is going to be robotic process automation. And this is kind of where we were at with AI tools before LLMs kind of took over. The idea being is that we have certain repetitive tasks that we do as business professionals, and we want to have a tool that can do that for us. So robotic basically mimics human actions process. It can follow a sequence of steps that lead to a meaningful activity using the process. Automation it has to happen without any human intervention. That's basically how they define that. The way that I would define it is you have an AI tool that can do menial tasks for you. An example is when I teach auditing, I talk about these things called confirmations, okay? And a confirmation is effectively a letter that you send to a third party to verify information. When I did confirmations back in auditing, they were the most miserable, tedious task because it's a form letter, but you have to go in and you have to change who the addressee is, and you have to change the updates and the details about what you're asking about. And you have to do that for like 80, 90 times. And so confirmation process is basically 10 to 12 hours of misery of just going through and updating information and doing that. Now we've got RPA tools that can do that in like 20 seconds. They can say, okay, provide your list of information, the details that you want in the letter. Where do they go to there? Updates it automatically, sends it out, and emails it to the contacts, and you're done. And so we move from a 10 to 12 hour manual process to like a 1 to 2 second automated process, where you can see a lot of benefits or something like that. All right, then we have kind of our new generation, which is going to be machine learning. And I tend to use the term LLMs in this area, large language models. Machine learning is not just LLMs, but this is kind of the one that we have a lot of insight with. Machine learning tends to fall under the area of generative AI, which within generative AI, we see ChatGPT, which is a form of that. It's hard to argue whether or not these are true generative AIs. When you hear AI scientists talk about this, they'll say large language models are not true generative AIs. They're just basically robotic parrots. I think one of my co-authors actually said a stochastic parrot, which is actually pretty clever, but trying to actually just provide the response that you're looking for in a given situation. Not to say that does not have value, but a generative AI would be more true human intelligence in the human evaluation. So trying to actually say whether or not these fall under generative AI tools is kind of it's an argument that we're not going to have in here, but an argument that people outside of this room have kind of consistently over time. The idea behind machine learning is that machine learning can actually mimic human actions and mimic responses at an expert level, depending on how your definitions are. So let's go into a little bit more detail on machine learning, because I think this is a fascinating one for us. So machine learning involves the computer's ability to learn from experience rather than from specific instructions. Okay, and we tend to utilize the term synonymously of machine learning and AI, but AI is not just machine learning. AI is actually kind of any development of artificial intelligence, whereas machine learning is a subset of that. And we're also going to talk about very briefly about the idea of deep learning. It's a complex form of machine learning. This is used very, very specific situations. You can kind of do some research in there. This is being used in medical field and geographic mapping is some of the areas that I saw when I looked about deep learning. We're not quite to the point where we're using deep learning in business and finance yet, not to my knowledge, but it's probably on the horizon very, very soon. But you use a lot more data and perform a lot more complex tasks than just traditional machine learning. But the idea behind machine learning is basically mimicking human actions. And if we're going to mimic human actions, then we need to have technology that kind of mimic human physiology or human brain. So with machine learning tools, we have something called neural networks. These are the engines of machine learning. So basically the idea is you think about the way your brain operates. There's a lot of neural pathways which information passes through. And I realize this is an AIS class and not a physiology class. I'm not going to test you on this, just kind of for context. But the neural pathways that your information passes through says, okay, I'm looking for a piece of information. There's a path that I need to follow to process that information, to evaluate, and then to regurgitate whatever the detail is. Same holds true for a neural network, is that there's actually defined pathways, but the way that you get down to a certain piece of point can actually change every single time. They can go down different paths. There's a lot of different pathways to the same point. Technically speaking, the way that they define it in the book is mathematical models that convert inputs to outputs or predictions. All right. Complex multinodal neural networks, these are the ones that actually enable deep learning. So these are the pathways that can actually go down much, much deeper. They're much more complex and much more evolved. But they allow machines to solve significant problems, but they also create significant model complexity. So basically what that means is that as we evolve these tools that actually are more emulate what the human brain is, then they're going to be able to be more powerful in their responses, and they're going to be able to provide more detail and more sophisticated analysis. The problem also comes is that we have comparability issues, we have consistency issues. Imagine that you answer a question one way on an exam, and then you go do something over a semester, and you're handed that same question another semester, later semester. Are you going to answer that question word for word verbatim the way that you answered it the first time? No, and that's kind of what we're going for as human intelligence, is that you would have the same idea, the same approach, but it was going to be a different articulation. And that's something that machine learning is very, very good at. It does not actually approach the same problem the same way every single time. There's actually a rational adjustment, which makes sense. However, there's also inconsistency in the way that it approaches the problem the same way or consistent. I would say like personality quizzes. Anybody ever done a personality quiz in this class? Like saying like, okay, what is your favorite color? And you have a list of 4 items and you should collect those. Or if you were approached in the street and asked a question, how would you respond? Like just basically kind of very, very vague questions. So you answer them one way a certain series of times based on your own personal traits. And you actually come back several weeks later and are given the same quiz again. What is the likelihood that you're going to answer every single question the same way that time around? Especially if it's not knowledge that you tried to retain. It's very low likelihood that you're going to answer every single question the same way. This is the sophistication problem we're talking about. Is because when you have complex systems, they think about a lot of different things and they think differently at different points of time. So the neural networks are kind of emulating our own activity and creates a lot of problems with respect to what predictability is going to be within the system, because there's no predicted path, there's no predicted output, at least not a direct predicted output. So let's go ahead and talk about some machine learning classifications, so applications. So most machine learning applications are designed to perform either one of 2 things, okay? First one's going to be classification. And this is pretty straightforward. Classification is just basically trying to assign labels dividing the input into output groups. So a very easy way to think about classification is a yes/no question. Does it meet a certain criteria or not? If it does, we say yes. If it's no, we can actually classify a little bit more detailed. We can say, all right, is something, if you're talking like a spam folder in an email, do we look at an email and say, this is spam, it has the characteristics of a spam email, we're going to put it into the spam folder, or not? It's still a yes/no question, it's just articulated differently. So classification is pretty easy. It basically is saying a condition exists or a condition does not exist. The other one's going to be a regression, okay? And this is going to be seeking to predict real numbers, all right? So trying to determine what the price of a house may be or what the revenue in the next quarter may be. Regression is a little bit more detailed, but it does take a lot of pieces of input and actually makes a determination based on what the values are. So regression is probably fairly familiar to you if you've taken a statistics course. It is the same logic that's held. It just utilizes more input variables to be able to make that determination. So as far as these applications go, there's a lot of different ways we can do this. And we can use combination of classification and regression to answer a lot of different questions. So the first two of these listed on this slide basically are kind of classification questions. So is it a yes or no question? So is it A or B? The answer is it A, yes or no? If, otherwise, it's going to be B. That's just a simple two-class classification, okay? It's going to be one or the other. The second one is still a form of classification, but it's saying it's different, okay? Yes is saying it has the characteristics of what I'm looking for. No is saying it's different. It has different characteristics we're looking for. So it's either A or it's not A, okay? Which means that there could be multiple possibilities of classification, but it's only looking for one determination or the other, all right? So anomaly detection. Then we actually have formats of regression and combinations of regression and classification a little bit later. So how much is a pretty easy regression algorithm. If it has all the relevant information, it can make a determination of what the math should be. And then 4 and 5, like I said, these are kind of combinations of these. How are these alike and what should I do? They take elements of both the regression and classification to be able to answer certain questions. And as we get more and more powerful with these machine learning tools, the better that they can answer these questions. So one of the things that's kind of in the crosshairs right now is self-driving cars. Should I stop or should I go left? Again, that's going to be a very subjective situation, especially if you've ever ridden on the roads in Kirksville. I don't think I'd trust a self-driving car in Kirksville, Missouri right now. But as these tools become more and more refined, we're going to see these become more commonplace to be able to answer very easy questions much more effectively. Okay. So what are some types of machine learning? By the way, make a note of this one. This is a question. This is a slide that I tend to ask a lot of questions about because I think this is a really important series of pieces of information to note. So this will be the study guide, but I will say there's a very high likelihood I'll ask questions about this particular slide right here on the exam. So supervised learning. This is basically an output set on a known set of variables. So if you're training a machine learning tool, you use supervised learning saying, I know exactly what the result should be. Let's see if the machine learning tool comes up with the same result. And this is generally going to be a very early phase of machine learning training, okay? Once we actually get past that, we have got something called unsupervised learning, where we use unstructured data where the output is unknown. So we can actually look at data. We can say, I don't know what the result should be, but I believe that the AI tool can parse this information better than I can. So supervised learning is knowing what the result should be. Unsupervised learning, we have no idea, but we have confidence in the machine learning tool's ability to parse that information. Now, in between there is kind of semi-supervised learning, where we have data that are labeled, but some labels may be correct or missing. And the whole goal of this semi-supervised learning training is to see if the computer can actually discern values for incorrect and missing outputs. So it's a little bit like the way that we would approach analysis in the real world. If you think about data analysis, we talked about that data cleaning approach and making sure that we have all the information that's relevant. A lot of times when you look at data, there may be values that are missing or headers that are missing, and we can't actually determine at face value what is missing, but we can certainly make an intuitive guess behind what the value should be or what the values represent based on our own knowledge and experience. Semi-supervised learning aims to kind of replicate that and make the determination. Even if we've got an incomplete data set, based on all what we do have, we can make a determination on what should be remaining. And so that's kind of advanced analysis. So semi-supervised learning is definitely trying to articulate and replicate what humans would do naturally. And then we have reinforcement learning, which I think is kind of the ultimate learning tool. This is basically trial and error. I tend to think of the current generation LLMs as to be a benefit of trial and error learning tools. So this is especially true if you go back even just like 2 years ago, going back to like ChatGPT 3.5. You would ask it a question, it would confidently respond what it thought the response would be. And then you would have to say, okay, that's great. Thank you very much. That's what I was looking for. Or if you look at it like me and say, that is nowhere near the correct answer. Here's the correct answer, and here's all the reasons you're wrong. And generally, ChatGPT would just be like, oh, you're right. I completely and totally botched that. Thank you very much for the clarification. It's learning from the process. It would give you a response, and it would say, it would seem like it just doesn't care what the response is, but actually, it would take the input and the feedback that you give it to clarify the particular piece of information and learn from that input. The interesting thing is that I think that we're getting to the point now that reinforcement learning is no longer as applicable as it used to be, simply because the chat response rate on the current generation of LLMs are so high with respect to accuracy. I actually tried to get into an argument with a ChatGPT during my seminar and auditing class, my graduate class, because it got a question wrong on the CPA exam, and it fought back. Okay, it fought back, says, "No, I'm afraid you're wrong. Okay, here's the reasons why you're wrong." And I said, "Okay, here's the deal. I teach this stuff. I've got a doctorate in this thing, okay? I'm 100% right and certain I'm correct, okay? You can't argue with me about this because I know this is the correct answer because I wrote the question." And it's like, well, it doesn't matter if you wrote the question. This is the particular standards. And so I did get a little bit angry at an LLM, okay? I know it's an irrational anger, but I did get a little angry. So we're reaching the point now that reinforcement learning has actually accomplished its goal. It's gone through enough iterations of particular topics, been trained on enough in detail that it actually knows what it's talking about. I don't think we're past that just yet. I don't think we're past reinforcement learning just yet. I still think that we still have a lot of work to do in that area, but we're getting a lot more. So last thing, I did this I think last year. I said, when we're talking about machine learning, what do we want? What's the ultimate takeaway? So I said, let's just ask ChatGPT. So I'm preparing to teach my accounting information systems about students about artificial intelligence. What's the single most important thing that I should know? You can tell this was an early version of ChatGPT because it didn't give me anything single. It gave me a whole lot of different things, okay? AI tools and automation, enhanced decision support, data and cybersecurity and fraud detection, ethical considerations, and continuous learning. I do think that some of these are very important takeaways, okay? And by the way, this is not on the test, okay? This is just mostly for your benefit. I do think ethical considerations, the ethical use of AI is kind of really prominent now. Has anybody been following kind of the Hollywood media and the artist industry on their concerns about AI right now? Hollywood's got a real problem because there's concern that actors' likenesses may be actually put into TV shows and movies, and they don't actually have to pay the actor. They can say, we have enough information about the way that you act. We can create a likeness that's very close to yours. And we're really close to that right now. We're not quite there, but we're really close, and eventually we will be. I mean, what do you start doing then? You start saying, okay, my likeness can never be used. How do you regulate something like that? It becomes really, really problematic if you think about this from the perspective of fraud, okay? If they can mimic an artist, a well-known artist who's got certain quirks and certain irregularities, they could probably mimic you, right? This is certainly becoming a problem on phone calls where people are getting phone calls from their loved ones saying, I'm in jail, I need you to send me $500 right now to make bail. So somebody sends a electronic payment to some sort of site, assuming that they're paying for bail, and instead it's scammers who are actually taking the money. They've replicated the loved one's voice because they heard a voice snippet right there. So yeah, that's certainly problematic. So if you've got a online profile where your voice is available right now, be very, very careful because that could be available. I will say that continuous learning is something that we're going to be knowing from. That's one of the goals of this project for this course that we're going to be talking about with continuous learning. In other courses, the idea may be if you're using AI tools that you're trying to bypass the learning process and bypass the work process. I do think that we can actually improve upon our own knowledge by using these tools. It's a little bit like playing a video game. Does anybody play video games in this class? I play video games pretty regularly, okay? Do you think that you are just wasting your time and just blurring headspace of anything when you play video games? Or can you actually learn something from a video game? Okay, I'll fight you on this one, by the way. Okay, I do think you can learn from video games, not necessarily traditional skills, but definitely skills that can be beneficial in the real world. Same is true. We talk about AI tools that can provide benefits in that regard. All right. Anything last words of information for the students? It's got a lot of words of information for students, but we only have 1 minute, so I'm not going to read them all. I'm just going to say AI believes in you, and I do too. All right. Have a good day. I'll see you all on Wednesday.